Hi there. Today's video is a recap on the activated carbon, which was homemade sugar carbon by 9 grams and 4 grams of graphite mixed in sulfuric acid and phosphoric acid and then cooked again. So first cell we'll test, it's on the carbon pads. They're not ideal actually. I discovered that the glue can actually go underneath the copper plate I've used here as the collector, and one of these had about 200 and something ohms from there to there on the graphite, where the other ones were around about 1.5 ohms. So the glue seeps under, even though it's clamped. Before I only glue the edges, but it's still, it could come in from under there. Okay, maybe there. I've been trying a piece of aluminium as well. I've tested out some aluminium. It's not too bad. You can't use 2 aluminiums. You only get 0.5 and bugger all milliamps. But if you use a piece of aluminium and a carbon collector, you're up near 1.5 volts with the same electrolyte. And I'm trying, instead of paper towel, I'm using printer paper just for a test. And for one of the cells, it's going to be plain graphite pads with one of these in between and another graphite pad, and plus the aluminium cell as well in that design. And with the 2 painted electrodes, it's sort of roughly painted. I sort of pour it on there. I'm going to use another piece of the same paper coated in the carbon as the separator. So it's going to be a carbon coated separator as a trial. Alright, we'll start with this cell and I'll be back. Okay, I have our first cell. It's double coated graphite pads separated with the plain piece of printing paper coated in the same carbon. Alright, and it's in the same electrolyte. So we'll just see if it's got any voltage. Not sure which side's going to be positive yet. Not that side. Okay, we got slight value there now. 0.02 voltage, and I don't think we'll have any milliamps, but the paper towel has to wet and everything else has to soak it up. So for a short circuit, change it to the 200 milliamp range. 0.01. Give it a quick charge. Charge voltage is set at just above 4 volts. We're off to scale there, we're above 200. And we don't want to overcook it now because the electrolyte hasn't soaked in. And we're at 1.5 and a short circuit. 200 milliamp range. 150. Not too bad for a little charge. So I'll let that soak up the electrolyte for about 10 minutes or something, and I'll get back. Okay, it's been a half hour soaking in the water. The voltage doesn't look too good for that little charge we gave it. So I think it might be earthing out through it, so I'm not sure. Put this on the 10 amp range. We'll give it about a 20-second charge. Okay, that's about 20 seconds. Disconnecting, and for a short circuit after 20-second charge. I dropped it off. Yeah. 400 milliamps and dropping 300. And for a little load test, we'll try the motor. And we're at 1.1 volts, 30 milliamp load. Yeah. Okay, I'll creep up the charge. I'll give it 1 minute and I'll get back. I'll connect that now and then I'll get back. Okay, it's been just over a minute. Minute and 0 point. And disconnecting. Stop monitoring. And we'll do a load test of 30 milliamps after 1 minute charge. I'll try it with a separator as well, not coated in carbon. The piece of paper could be too thick, not the right type, could have wax on it. Sometimes printing paper, lead pencils won't draw on it because it's got wax on it, or areas of wax. It's looking okay. Probably still needs to soak a bit longer. I'm impressed with the aluminium ones. They increase the short circuit current quite a bit. What did I have? I had 400 with 2 graphite pads, 400 milliamps on a short circuit, and I substituted a plain without any carbon on it, and got 600 milliamp short circuit. That's 200 up. Cell didn't deliver any more power though in the end, but it was a better collector, I think. These pads are a bit sketchy on their resistances from each one, which is slightly different, and they're around about 1.5 to 4 ohms, so still not perfect. I never bought ones. Okay, it ran 2 milliwatt hours on a 1 minute charge, and a voltage bounce back is 1 volt, say, and 3 minute runtime. So I'll give it a we'll try a 2 minute charge and see what happens. Let's reset the graph. I'm only resetting the curve because it's easier to monitor the time when it's set at 0 over here. I'll connect the charge, monitoring, and I'll be back in 2 minutes. Okay, we're at 2 minutes. The voltage has sort of hit a plateau. It's not going anywhere. Disconnecting the charge and stop monitoring, and we'll do another discharge of 30 milliamps after 2 minute charge. We have to beat 2 milliwatt hours if the cell's doing anything with longer charges. It's looking okay. It's holding its 2.1 for now. Alright, I'll get back. Okay, it just ran out. It's not so grand looking. It's 3 milliwatt hours. We did beat it, and we got an extra minute on our run time, but we had a 2 minute charge. So we didn't get double. Yeah, so we'll go for a longer charge, creeping it up to 5 minute charge. I'll be back. Okay, slightly over, nearly 6 minutes, but something terrible happened after 3 minutes and 5 seconds. At least the voltage bounced to 2, but I think we're under. Doing a test after 5.5 minutes of charge. We're way down. So charge voltage definitely too high for the cell. Looking really bad now, and could be the paper's not that good. Yeah, it's not looking so good, so I'll stop it and we'll see what we bounce back to. Not much at all. I think I've shorted the cell out, so I'll turn the voltage down for the next cell. About 3 volts will be on, and I'll try the aluminium plate in the current cell. I'll swap one of the pads over and I'll get back. Okay, we're at 1 minute's charge. I'll just, with the aluminium plate I should say. I'll disconnect the charge and we can do a test. That's 1 minute. Oh, we're dropping in voltage heaps. No, aluminium one's not working too green. Could be the separator surfing out. Just checking it. We just dropped right off then. Maybe bad connector. Alright, slightly better. But nothing interesting. It's working better the other day, I'm pretty sure. No. Have it out of the water. I'll give it another charge and I'll get back. I see. The voltage is dropping, but the milliamps went right up. It was 170 milliamps or something when it was at the higher voltage. And as it slowly drops in voltage, the milliamps raising. See? Weird. How long's that been? 1 minute and 39 seconds, so we'll check that out. Not holding my breath though. Nah, look at that, it's getting worse. Right, bad idea. Short circuiting. Zerch. Alright. I'll swap, I'll go to the paper towel membrane and see what happens. Okay, back with the double carbon pads and a paper towel membrane coated in cellulose acetate. We're down to 80 milliamps. This time the milliamps is going down, not up. And 2.5 volts there. 2.587 volts. And 1 minute 18. Disconnecting the charge. Alright, we'll do a test now with a separator in between. Alright, so the original cell's working again, so the higher voltage might be arcing through the paper perhaps and causing a direct short, I'd imagine, because I've just pulled it out of the water and you can't really see any short circuits. Not to say there's not any in there. Looks actually quite clean. So yeah, but that didn't work with the aluminium plate or the double carbon pads. Alright, we'll see if we get 2 milliwatt hours with this 1 minute charge. We probably will because we're dropping right now. I'll be back. Okay, same milliwatt hours, 2 milliwatt hours, but it might needed a little bit more and it would have ran up, and the voltage bounce back is not too bad, 0.9. So I'll give it a 5 minute charge now and see if we're getting any improvement. Okay, within 6 minutes. With the paper towel membrane, the charge curve's a lot stabler by the looks of it. I might stick with the paper towel membrane. Maybe. Alright, so that was 6 minute charge. Discharging 30 milliamp load. Okay, alright, I'll get back. Okay, back. It ran for 6 minutes on a 6-minute charge. We got our time back, no power, and 4 milliwatt hours. Alright, so I'll give it a 10-minute charge and see if it increases. Doesn't look very good for just homemade carbon. The manganese dioxide definitely has a much larger punch to it, because previously the cells of the same size were running 32 milliwatt hours. Yeah. Alright, so I'll give it a charge up for 10 minutes and I'll get back. Okay, it's 11 minutes. The charge curve is stable looking. And milliamp draw is, wait for the meter to turn on, 20 milliamps left, 30 to 20, it's fluctuating. Alright, disconnecting that. Yeah, stop the monitoring. And ready for a discharge after 10-minute charge. Hopefully we get more than 4 milliwatt hours. It is double carbon of the same type. Looking okay, but it did that before too. Alright, I'll get back. Not looking good for the home activated carbon. I don't think it got hot enough, to tell you the truth. It was in those insulated little bricks I made. But 5 milliwatt hours, 7-minute run on 11-minute charge time. So, well, it's looking a bit disappointing. I'll give it another longer charge, 15-20 minutes, because the cells probably, I'll throw it away if it doesn't work. So I'll be back then. Okay, we're at 19 minutes and 56 seconds, so close enough to 20 minutes. So I'll disconnect the charge and stop the monitor, and we'll give it a run. 20-minute charge. Hopefully get more than 5 milliwatts. Alright, I'll let it do its thing and I'll be back. Okay, after 20-minute charge it only ran for 8 minutes and 6 milliwatt hours, so homemade activated excuse me. Yeah. Homemade activated charcoal. I'm gonna have to redo that one again, I think. And probably I should mix it with or have one side manganese dioxide and the other side this carbon here, because it doesn't look like it's that great by itself. Alright, thanks for watching. Just a small update before I post the video. This one's shop bought activated charcoal or carbon. 4 grams smeared over this little area. I've taken a little square out. Got it on charge. It's only been on charge for about 20 seconds, creeping up to a minute now. Cells over here. Just a graphite. I got it offset a little bit, so we're not got the complete surface area like the other ones. Okay, but look at this. This proves I make bad homemade activated carbon. 800 milliamp short circuit just then, and I'll just put some charge back in, 20 seconds. Okay, that's enough, that was 18. And for the motor run, and we're sort of slowly dropping, but the motor is running 120 milliamps. So it's cheaper probably to buy activated charcoal. I'm actually making some more feather carbon out the back. It's been cooking for 20 hours, but not straight. I've done 5 hours a day, so I don't know if it's going to turn out. And it's on its final 450 for 2 hours burn. So there's a lot of bang in your butt for shop bought charcoal activated carbon, and it's on the paper towel just to keep it consistent as the other tests. It's the same binder mix. There was 4 grams of activated carbon and 10% binder, which I'm using the cellulose acetate as the binder, and we're still at 60 milliamps, 1.3 volts. So I haven't really achieved activation yet, so it's quite tricky. You'd think just heat, but I don't know, there's something more to it. I've got another container. I sort of made a refractory cement crucible with a little lid. I might keep the can around it because that will help seal it. That little lump goes into the hole anyway, so I'll test that out when it dries. It needs a few more weeks. That should eliminate some of those metal particles going into the carbon. I think the I was reading on a paper that carbon can separate the nanoparticles of the metal at a lower temperature. So I think that's what's going on in there. It's a catalyst. The carbon's acting as a catalyst at 800 degrees when it's up high. So there you go. Shop bought carbon's turning out to be better for me at the moment. So we'll see what that feather carbon comes out. Hopefully it's formed. I put 8 grams of urea in it, but that's on another video. Alright, thanks for watching. Just a slight update. It's a 2-layer shop bought activated carbon on the data logger. And we're at a minute and we're still at 2 volts on 30 milliamp load. So it's looking way better than my homemade carbons. So I'm probably wasting a lot of energy for nothing. Oh, come on, what happened to the data log? There we go. And we might even get 2 minutes. And that was a 3-minute charge. Just under 4, just under the 4 notch, if you can sort of see it. The 4's that side of it. This will make the test. This, if it produces more than 5 milliwatt hours, it's way better than my homebrew activated charcoal carbon. Yeah, we got 2 minutes and we're 1.9 volts. I'll be back. Well, the cell's already beaten the homebrew carbon 6 milliwatt hours already, and it's 1.1 volts. Same electrolyte and everything, same graphite plates. That's a bit heartbreaking. Yeah. Alright, I'll get back when this finishes. So we're probably looking at 8 milliwatt hours. That's still not that impressive, but it's double carbon. Okay, we just finished. We got 7 milliwatt hours and 10-minute run time on a 3-minute charge. So that's shop bought activated charcoal carbon, put on paper towel. Probably only a total 4 grams all over the towel. So each cell probably 0.1 or 2 of a gram. Alright, thanks for watching. I couldn't help it. I put a small piece of manganese dioxide paper towel under the 2 other layers of shop bought activated carbon, and look, we're 3 minutes at 2 volts. Manganese dioxide makes a great difference. Probably the reason they use it in those carbon manganese dioxide cells. But just an extra piece. It's only the piece I put in there only went up to around there. About this big. And the results are pretty good. 4 minutes at 2 volts, 30 milliamp load. And 4 milliwatt hours already, and we're at 2 volts, so we're going to 20 milliwatt hours perhaps. Amazing result difference, just an extra layer of manganese dioxide tau. Wow, I can't beat that. Alright, I'll get back with this update and try not to add any more to the video. Look at that, amazing difference, 14 milliwatt hours, 15-minute runtime, 1.3 volts still, and that was a 3-minute charge. Just adding an extra piece of manganese dioxide, which was recycled out of a brand new bought zinc carbon cell battery. So it's not actually pure manganese dioxide being mixed in any carbon. It's already mixed and bought from a battery. So I'm going to look into buying a jar of manganese dioxide pure and try mixing it with my own carbons and see what sort of effect I'm going to get. Alright, I'll be back. Alright, we're still running, 32 minutes. We're down to 0.65 volts and 23 milliwatt hours. So that's the power of manganese dioxide for you. That's amazing, actually. What was it? 5 milliwatt hours versus 23 so far. That's phenomenal, I say. Alright, I'll get back when it's done. Okay, it's finally finished. 24 milliwatt hours. I just finished just after I filmed it, and 35 minutes. And the voltage recovery is 0.985 and increasing. And we'll see what it's got for a short circuit after this time. Okay, short circuiting, 10 milliamp range. 10 amp range. 150 dropping. That's still not too bad. Alright, that's the end of this video. I'm going to play with the cell some more and I'll post the video. Thanks for watching now.